Okay, hi. So we're looking at Unit 5, multiple choice questions, particularly some of the ones that most students answer incorrectly. First, we'll take a look at the Part C progress check. So this is what I see as question number 5. The total cost in dollars to order X units of a certain product is modeled by C of X equals 7x squared plus 252. According to the model, for what size order is the cost per unit a minimum? Okay, so take a look to see at what is supposed to be a minimum here. It's not the cost at a minimum, it's for what size order is the minimum. And the order we can write as the cost over a unit, cost per unit. So usually we write cost per unit, but we're basically dividing. So I'm going to take the 7x squared plus 252, and I'm going to divide by the unit. So this is what's going to tell me about my order, and I want my order to be a minimum. So that means I need the first derivative. So I need the first derivative of y, so I'm going to simplify it since that will be the easiest way for me to write the derivative. So y is going to be 7 plus 252x to negative first power. Therefore, y prime is going to be up. I don't know if I said 7x, but it should be 7x. So therefore, y prime is going to be 7 minus 252x to the negative second power. So now what I want from here is to set this equal to 0. And if that's the case, I'm going to rewrite this a little bit and add over the 252, I'll change color here, 252 over x squared on the left side of the equation, okay, just by adding it over, and equal to 7. So that's going to give me the ability to start solving for x. So I'm doing this pretty quick because it's a multiple choice. It should be relatively quick. Cross multiply. And when I divide this by 7, I actually get 336. Great. And it should be something easy to solve. So we're going to say x is 6 because x is the number of units. We don't need the negative. So now we know that the answer is 6 units. And that would give you minimum cost. If you want to go back, if you have extra time to make sure it is a minimum, you can do that. But the answer would be 6. And that is choice B. Okay, so here's another problem from the Part C progress check. And it says, let C be the curve defined by x squared minus y squared is equal to 1. Consider all points xy on the curve C where x is greater than 1, y is greater than 0. For which of the following statements provides a justification for the concavity of the curve? Okay, so taking a look at this, I'm going to do something that's not really the best method if we had to do like a free response, or maybe it is. I want to know what y is if, let's say, I wanted to graph it. So if I add the y squared over and I subtract the 1, I get x squared minus 1. To get rid of the square, I need to take the square root. And this is going to be positive or negative. So this is not a semicircle like the square root of 1 minus x squared. So what happens is when you're graphing it, instead of it going this way, it ends up going the other way. So it's the positive and the negative square root. The key thing here is that you don't necessarily need all bits of this information, considering that x has to be greater than 1. So let's say you decided to start plotting points where x is greater than 1 and y is greater than 0, so above the x-axis. So you would start plotting, okay, you'd get plug in 1, you get 0, so this makes sense. And then let's say you plug in 2, you get 4 minus 1 is the square root of 3, so you plot it somewhere. And then you plug in 3, you get the square root of 8, which is larger than the square root of 9. So you can kind of see how this curve, and you would know it's a curve because, you know, you got the squares here and you got the square root there, kind of give you this curve here. And so once you understand that that's what this equation would give you, okay, for x is greater than 1, y is greater than 0, you know that you're working with a piece that is concave down. Okay, so if I know that this is occurring, I could kind of narrow down my answers here. So which of the following statements provides a justification for the concavity of the curve? So you want that y double prime is less than 0 because it's negative, it's concave down. So you don't want that it's greater than 0. You want that it's less than 0. And so that gives you either choice A or C. So by the way, that's what this is concluding. All right, so now let's take a look at what else is being said here. So if let's say you were to take the derivative, you have 2x minus 2y, dy over dx is equal to 0, and you isolate dy over dx, you're going to get x over y. Okay, because you're dividing to negative 2 by negative 2. It's the same as 1. So now the derivative of this would be quotient rule. I'm running out of little space here. I'm explaining a lot and drawing a lot. You don't really need. Okay. So if we take the second derivative, and you don't even need the notation. I don't know why I'm doing it. I'm wasting time because it's multiple choice. Bottom times 1 times the derivative of the top. So you have 1. I'm kind of talking slower than I'm actually doing. So 1 times y is y. Let me kind of catch up to myself. Minus the top times the derivative of the bottom. And the derivative of y is 1, but we write dy over dx, and the bottom is squared. So we know dy over dx is the same as x over y, and I need some more space, so we're just kind of substituting, simplifying, so we got y squared minus x squared over y, and we're multiplying it by 1 over y squared if you do keep, change, flip already. Okay, and believe it or not, we're almost done. So we can see that in each of these answers, or I'm not sure if you can see here, but they are there. You're dividing by y cubed, okay? So where are we getting this numerator from? Well, y squared minus x squared, okay, is the same as taking the original equation and subtracting the 1 on both sides and subtracting the x squared and adding the y squared on both sides. So this right here is the same as negative 1, which leaves us with our final answer. C would be our answer because y double prime, okay, our second derivative is y double prime, turns out to be negative 1 over y cubed, and we know it should be less than 0 for the concavity for this curve. Okay, so for this particular problem, let f be the function given by f of x equals x squared minus 9 over the sine of x, and it's on the closed interval from 0 to 5. Okay, so of the following intervals, on which can the mean value theorem be applied to f? Well, if it's mean value theorem, makes sense, got to be on closed interval. But it also has to be differentiable on the open interval from 0 to 5. Okay? So that's why if you start to look at Roman numeral 1, 2, and 3, it starts talking about, hey, it being continuous on 1 to 3 and differentiable continuous on a closed interval from 1 to 3 and differentiable on the open interval from 1 to 3, and so on. So that kind of makes sense. Everything is running through, but in order for our function to be differentiable, that means that it can't be f of x has to be differentiable everywhere. There can't be like any sort of discontinuity. So if you take a look at the sign of x, we do not want that equal to 0. So let's try to solve where x would be equal to 0. So let's start talking about that. Think of your sine curve. So its answer is 0, 0, and pi, and 2 pi, and so on. So pi is the same as 3.14. Okay, so it's non-differentiable there. And so everything from 0 to pi, let me get a different color here, is perfectly fine. So from 1 to 3, that is a good interval, okay, to use. So Roman numeral 1 is fine. So let's take a look from there on out. So 4 to 5. So let's take a look at 2 pi, okay? So 2 pi is the same as 6.28, okay? Well, 6.28 is way off, okay, from 5. So this is another perfectly fine answer. So let's take a look at 1 to 4. Well, 1 to 4 has 3.14 in it, so that ain't good at all, okay? And so Roman numeral 1 and 2 would be perfectly fine, and that is it. That is our answer. It is C. Okay, so the last problem that we just finished up, didn't realize that was from the part A of your Unit 5 multiple choice progress check. So let's take a look at the next one. So f is given by the function f of x, which is the sine of x times the cosine of x, over the quantity of x squared minus 4 on the closed interval from negative 2 pi to 2 pi. On which of the following closed intervals is the function f guaranteed by EVT to have an absolute max and absolute min? So for EVT, it needs to be a continuous function. Well, if it needs to be a continuous function, then very similar to the last one, we can't have this being divided by 0. So x squared minus 4 is equal to 0. We get that x is equal to negative 2 and 2. So we need to make sure that those values are not included on our interval. So if you take a look at A, well, negative 2 and 2 are both in that interval, so we can't use that. B is including the negative 2 and 2, so that ain't good. So a bunch of red marks there. And C is good. It's very good. That is actually our answer. So from negative 1 to 1, EVT can be applied. Okay, for all our MVT, EVT, IVT, all those theorems, your function needs to be continuous. If you take a look at D, okay, from pi over 2 to pi, that doesn't work out because you have, not the negative, you have that positive 2 is a value in that interval, so that ain't good at all. And we reject that as well as the A and B. So let me clear the ink and say once again that the answer was C. Okay, so there's one more that I want to go over with you from part A. This is, you can see, my cursor is still pointing at number 8, is my number 8. It may not have been your number 8. So you're given this table of values. X is increasing from 0 to 4. and it's for selected values in that interval, and we're given the values for f of x, and we see that most of them are positive, one of them's negative. So let's continue. It says selected values of a continuous function. Okay, that's good. So that means that we can use any of these theorems, as you can glance down and see, as part of your choices, because it's a continuous function, are given in the table above. The only one that's the tricky one is the MVT, because not only does it have to be continuous, MVT is the one that has to be differentiable on that same interval. Okay, so it's continuous from 0 to 4, but is it differentiable? So which of the following statements could be false? You want to take a wild guess here. It would be B, because we don't know if it's differentiable or not, and it could be false. It could be true, but it could be false. We're not guaranteed to have a value of C such that f prime of C is 4. By the way, where they're getting 4 is by doing 18 minus 2, okay, and 4 minus 0, and that's where they're getting that answer, is the average rate of change. But I guess the point of the story, once again, is to know your theorems inside and out. So since you need to know EVT inside and out, like, you also need to know like FDT inside and out, or SCT. All those things have a certain procedure, and you need to know why the steps are there, and they'll help you with some of the other problems. So let's take a look at number 9. Okay, so this is continuing on into part of the multiple choice that's in Unit 5, Section B. So we're given this graph, and it says, let me make this big. Okay, I couldn't see that. So the graph of f double prime, the second derivative of the continuous function f. All right, so we can see that we have the graph of f double prime is shown above on the closed interval from 0 to pi over 2. We can see that. On this interval, f has only one critical point, which occurs at x equals pi over 6. So this is f double prime. X equals pi over, not 6, but 16. Is going to be a critical point, not for the second derivative test, because that's where we change concavity, and right now it's still concave down. So it's the critical point for your relative extrema. So it's a possible min or max. And it says, which of the following statements is true about the function f on this interval? So we have to take a look at the choices. Let me pull them up. Okie dokie. So it says that f has a relative minimum at x equals pi over 6, but not an absolute min. And then B says that it is an absolute min. C says it's a relative max. And D says it's the absolute. So we have to determine whether it's a min or a max, and then we have to determine whether it's an absolute or not. Okay, so let's actually go through some basic curve. Okay, so if you remember from my lesson, if it's on a closed interval, let me erase that and not cross it out. So we have an absolute min, okay, and that's at the one critical point that we have on our closed interval. Okay, another basic curve. We have one absolute max, okay, where it is our critical point on a closed interval. Okay, so if we only have one point, okay, and it's a min or a max, then it has to be the absolute, depending on what our curve looks like. So that's the situation. So it's either going to be either choice B or choice D. Okay, so I start crossing out A and C. So it is going to be an absolute. So now let's take a look at actually finding whether it is a min or a max. So if we have that it's a min, then using the second derivative for relative extrema would help out. So what's going on at pi over 16 in the second derivative? Well, pi over 16, much like everything over here, is positive. Everything is positive there. So it's greater than 0. When this occurs, when it's greater than, this means that at x equals pi over 16, you have a relative minimum. Okay, and like I just went over, okay, it's not just a relative minimum, but it's an absolute. So it turns out that our answer here is B. Okay, so let's take a look at this function, and it's a graph of the function f prime. A lot of things going on with it. They tell you, they give you that. They tell you it's the derivative of a continuous function f. Okay, and shown above is the interval from -3 to 7 exclusively. Okay, which is what happens with derivatives. Which of the following statements is true about f on that interval? Okay, so what do we know about f? So wherever we have critical points, okay, or critical numbers, critical points, whatever we have, there could be a relative min or max. So let me pull up some of the choices we have here. So it starts talking about the relative extrema, so that's okay. Sorry, I moved that. It's just combining wherever you have a min or max. So it doesn't matter which one you have, you just need to know how many. So if you remember FDT, you want to consider where you have all your critical points. It's sometimes where f prime is undefined. Okay, that's where f is non-differentiable. In most times, or most cases, in that step, we're saying, hey, f is differentiable, or f prime is defined. But I always explain, hey, that means we don't have any extra or more critical points. But in this case, you do have critical points. There are plenty of places where f prime is undefined, okay? So you can see that here and here. So you also want to see where f prime is equal to 0, because then that would be critical points as well. And it's equal to 0 at this point and here, just wherever it's crossing or touching the x-axis. Okay, so what you want to see is some sort of sign change, okay? Negative to positive or positive to negative. So at x equals -2, it went from positive to negative. So that is, start tallying it up, 1 relative extrema. Okay, so let's look at -1. So it's still negative. It's negative to negative. Okay, we want a negative to positive, so that's not a relative extrema. So let's take a look at 0. It changed from negative to positive, so that is another relative extrema. Over at 2, when x is equal to 2, it didn't change sign. It was positive and then positive. That ain't good. So when x is equal to 5, it was positive then negative, so we have relative max. That's good. And when x is equal to 6, it went from positive to negative. Okay, so it was below the x-axis, it changed from negative to positive, and then went to above the x-axis. So that means that we tallied up, we have 4 relative extrema. So it's not going to be choice A, it's not going to be choice B. So how are you going to investigate now the 2 points or 4 points of inflection? So that's where the slope of your tangent line, So the slope of the tangent line for f prime would be f double prime. It's got to change sign. So that means it's got to change from going up to going down. So I got to erase all this marking that I had to determine, yeah, you do have 4 relative extrema. Okay, so don't forget, you're going to have relative extrema where your first derivative is equal to 0 or where it's undefined. All right, I'm trying to erase this. Okay, so here we go. We're going down along the line segment, and then we're going up for slopes of tangent lines. So we do have a change of concavity. Let's try it again. We're going down, and then we're going up. So here is another change of concavity, so that means it's a second point of inflection. Okay, we're going down, okay, after coming up, so that's a third point of inflection. And we're going down. I feel like I missed one because I counted 3. So it's either 2 and I messed up, or it's 3. Or it's 4. So let's actually erase and see this again. Ta-da! So here we go. Tangent lines drawn in. Tangent lines drawn in. So we do have a point of inflection there. Tangent lines drawn in. Tangent lines drawn in. We do have a point of inflection here. Tangent lines drawn in. Tangent lines drawn in. We do have a point of inflection here. I think I missed that one. Tangent lines here. Tangent lines there. So point of inflection somewhere between x equals 3 and x equals 4. And tangent lines here. Keep going down. This keeps going down. There isn't a change. Okay, so once we're clear, we have 4 points of inflection. And, whoa, that's a lot of space. So going back, since we have 4 points of inflection, our answer is D, and we're done. Okay, so there's actually one more problem that I want to go over, and I don't have a picture of it, but I saw that students were having some difficulty with it, so let me do my best to try to describe it, and see if it matches up with any of the multiple choice that you did. So f of x is negative x cubed plus 3x squared plus 24x. And we want to know what the absolute max of f of x on the closed interval from negative 6 to 6 is. Okay, so I don't have the choices, obviously, so I'm going to treat this kind of like a free response type question. Okay, so I apologize for that. So the first thing I'm going to do, even though it's not free response, it's multiple choice, I'm just going to write any sort of notation here. So I'm not writing f prime of x, just f prime. So I find that. The reason I am doing this, because if it says absolute max, I want to do EBT. And that's my first step. And I look at that, I see that it is defined. So f is differentiable. And so everything's good to go to set this equal to 0 to find our critical points. Well, if I set this equal to 0, best way to solve this is add over all of these terms and factor out of 3. So that way 3 I know doesn't equal 0, but I can easily factor this. X squared minus 2x minus 8. Okay, so x times x is x squared, and 4 times 2 is 8. If it's a negative 4 and a positive 2, that will combine my outer and inner terms to be a negative 2x. So x equals 4 and x equals negative 2, okay, are possible relative mins or maxes. I'm not going to do the whole table and set it up. I need to know the absolute max. So if I'm doing EVT at this point, I'm just taking those x values that I have and plugging them into my function. But it's not just my critical points. You have to include the endpoints. So I have 4 different numbers to test. In order, -6, -2, 4, and 6. All right. So taking a look at the function itself, it's not the best to work with. So I'm going to factor out an x. Maybe this will be easier for me to start plugging in because it did not have a calculator symbol. This is a non-calculator thing. So -6 squared is 36, but it's going to be negative. And -6 times 3 is a -18, and a -36 is going to be a -54. But I'm adding 24, so I'm getting -30. Is this right? But I'm also multiplying it by the -6. So a negative times negative is positive, and 30 times 6 is 180. So I'm going to do the same thing with -2. I had to work this out earlier. So if I plug in -2 here, 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 and there, wherever I see x, I'm going to get -28. When I plug in 4, okay, I did it earlier, I get 80. And when I plug in 6, I'm getting 36. So I guess the main thing is to just kind of stick with doing this part, taking the first derivative, setting equals 0, know the other values to plug in, because the plugging in is taking a little bit of time, just because it's multiple choice. It should be faster. But in any case, the absolute maximum is 120. I'm sorry, 180. Because it's the highest y value on the interval. This is what you're looking for your answer. If you are looking at your multiple choice, this would be choice D. Now, if it had asked for the value of x in which there's an absolute max, or you were to describe it if it's free response, you would say it's x equals -6. But you don't want to choose that. I believe that was choice A. You don't want to choose that as your answer. You want to choose the 180. So just double check your questions itself to make sure that you're answering them correctly. And there you have it. It's everything I can find that I should cover, since most students were getting it wrong as of this posting. Okay, so take a look over your work and good luck.